Welcome back to general session. If you're coming in, please find a seat because we're going to start right on time. So I'd like to welcome up Brandon Bennett from Team PiCon, correct? Who's going to give us an overview of their hack from the hackathon.
Okay. Welcome. I hope everybody's nice and sleepy because this is going to be pretty boring from lunch. Anyway, so my name is Brandon Bennett. I worked on a team with 3 other people, and we created a Raspberry Pi-based console server. So you must be thinking to yourself, this must be pretty easy, right? You take Raspberry Pi, you plug in serial port. Hey, look, I got a Raspberry Pi console server, right? So we decided to try to take it a step further. So we really tried to look at when you actually need a console server and how we can get connectivity to a brand new POP or a brand new data center or something where we don't necessarily have connectivity yet. So has this ever happened to anybody where you're trying to talk to somebody from like Smart Hands or from the local colo, maybe they don't even work for your company, and you're trying to get them to get an IP address or at least share their screen so you can get on the device. So we tried to solve this problem. So what we did is we took a Raspberry Pi that costs 35 bucks. You got a USB serial adapter, you can plug it in. You can also add a 3G or 4G card. And what we actually wrote was software to have the Raspberry Pi call back into the server. So as soon as the Raspberry Pi comes up, it starts running our software. It monitors all of its interfaces and reports its USB ports and all of its IP addresses back to a central server. So this allows us to find out exactly when this comes online. So you got a 3G, 4G card plugged in here, you got your USB card plugged in here. All the tech has to do is take this, less than $50 device, plug it into your console server, and now we have access, right? So no experience needed on the other end. If this thing gets lost, big deal. It's cheap, right? We can replace it. We can send out hundreds of them. So quick demo. Here is the web interface. Let me make that a little bigger. That was the wrong button. All right. So here's the web interface that we created. So pretty much after the console registers in, we store that in a database somewhere. And of course, it's not working right now. Live demos, don't ever do them. So each one of the console servers actually comes in, registers its IP addresses and its console ports. You can see them directly right here. The console port we have right here is called Luke. And if it was up, the status would be red here on the side. It's not. Fun. Okay. So why did we use a Raspberry Pi? It's inexpensive. It's Linux-based, so we have all the same stuff that you would be used to on Linux. It's puppetable, it's chefable, it's Ansible-able. It has a wide range of hardware. Because it's Linux, you can plug in most 3G or 4G Linux-based or Linux-supported cards. We don't want to try to do our own encryption, right? Doing your own encryption is stupid. So we get Linux encryption with this, which means you can integrate this into your Kerberos system or use simple SSH keys. And then finally, it's got some pretty decent hardware on it. These are the Raspberry Pi 3s. If you look at your console servers that you have now, you'll find out they probably do run Linux already. They've got like 4 megs of RAM in them and like 8 megs of flash, right? You can't even run Chef on those if you wanted to. So our next steps here is in this web interface to actually have a console access directly in there. Also provide an API to allow robots to do it. There's no reason why once the device comes up that I need to sit there and still type in commands. Why not have a robot come in, find out there's a new device that popped online, and automatically start configuring that for me. We are currently just polling all the interfaces for both the USB serial ports as well as the interfaces using some sort of event notification like UDEV would make this a lot better. And then finally, there's no reason why we have to be limited to this small form factor, right? The chips that are in these USB adapters are really cheap off-the-shelf chips. If you buy one at a time, you can get them for like $4. If you buy like 100 at a time, you probably get them down underneath $1. There's no reason why you couldn't design your own board and actually create a full functioning console server out of this for thousands of dollars cheaper than what you're currently paying. And finally, here's everybody that I worked with. It was an honor working with everybody up here. They're very smart, and it was a whole lot of fun. So thank you guys, and that is it. If you want to check out our code, it's ugly right now, but everybody's super excited about continuing on working on this. Pull requests are welcomed. Thank you.